Okay, students. In most of the equilibrium system around us, the system can be homogeneous or heterogeneous. Equilibrium. So if you look at the slide, what is homogeneous equilibrium? Homogeneous equilibrium when the system, all the substance in the system in the chemical equation are in same state. What about heterogeneous equilibrium? Heterogeneous equilibrium is a system when all the substance in the chemical equation are in different state. How we characterize the chemical reaction to homogeneous and heterogeneous equilibrium? Let's look at the example. Below the homogeneous equilibrium, we have the reaction between hydrogen and nitrogen gas forming ammonia gas. If you look at the example, the hydrogen gas is in gaseous state, the ammonia gas is in gaseous state, and the ammonia gas is in gaseous state. The nitrogen gas is in gaseous state also. And if you look at all the state of the components in the chemical equation, they are all the same, which is the gaseous state. What about heterogeneous equilibrium? Let's look at the example given. We have a reaction between water, sulfur trioxide, and forming sulfuric acid. If you look at the equation, the water is in liquid state, sulfur trioxide is in gaseous state, and the sulfuric acid is in aqueous state. They are all in different states in a chemical reaction. So the equilibrium in the reaction, we call it as heterogeneous equilibrium. This is how we define homogeneous equilibrium and heterogeneous equilibrium by looking at the phases, the state of all the components in the reaction. Hello students, now we go to the second part of 6.2 equilibrium constant. At the end of the lesson, students should be able to write expressions for equilibrium constants in terms of concentration, Kc, and partial pressure, Kp, for homogeneous and heterogeneous systems. Okay, let's go to the next part, the second part of objective 6.2, equilibrium constant, how to write the equilibrium constant in a form of concentration or Kc, and equilibrium constant in a form of partial pressure, Kp. Before this, you already know the homogeneous and heterogeneous equilibrium. In both cases, we can write down its own equilibrium constant. Let's look at in the first example, in homogeneous equilibrium. We have the reaction between hydrogen and nitrogen to form ammonia. And if we look at in the equation, all the components are in form of gases. Normally in the question, you will be given partial pressure if the reaction involves gaseous state. So if you are given with partial pressure, then you need to calculate the equilibrium constant in a form of partial pressure, Kp. As usual, as we look at in previous slide, equilibrium constant is equal to anything concentration over anything anything product over anything of the reactant. In this case, we will use partial pressure. So goes to partial pressure of NH3, and NH3 now have 2 as its coefficient. So ammonia we raise to the power of 2 here. It will be divided with the partial pressure of the reactant. Firstly, we have nitrogen, N2, partial pressure of nitrogen. Note, you have a dot symbol here. It means you have to multiply with the partial pressure of another reactant. Now the another reactant is hydrogen. Note that we have a coefficient 3 in front. So partial pressure of the hydrogen we raise to the power of 3. So now the equilibrium constant in a form of partial pressure of the equation, reaction between hydrogen and nitrogen to form ammonia, is partial pressure of ammonia raised to the power of 2 divided by the product of partial pressure nitrogen and partial pressure hydrogen raised to the power of 3. Next, let's look at in heterogeneous equilibrium. If we have a heterogeneous equilibrium, given to you example of the equation. Look at the equation. It is a heterogeneous equilibrium because the phases of all the components are in different state. We have liquid reactant, we have gas reactant, and we have aqueous product. So as one of the component is in aqueous state, normally you will be given with concentration of the component. So if it involves concentration in the calculation, we will write equilibrium constant in a form of concentration or Kc. As we look at in many slides before, to write down the equilibrium constant, it must be concentration of the product over concentration of the reactant. So H2SO4 is our product, SO3 is our reactant. So comes concentration H2SO4. Remember the square bracket. Please don't leave out the square bracket to indicate the concentration of H2, the concentration of the component. Now it will be divided by concentration of the reactant SO3. Please note that I don't include concentration of water, as water has a constant density, so it will not involve in calculation of Kc. So this is how you write down the equilibrium constant in a form of concentration. For this reaction, concentration of sulfuric acid divided by concentration of sulfur trioxide. So as a summary, in this slide, you already know to write the equilibrium constant in a form of pressure, Kp, and equilibrium constant in a form of concentration, Kc. Now it comes to the end of the slide.